Hello, my name is Rogelio Blanco and I'm going to explain example 7. In this example, we are going to use a 7-segment display. Why is a 7-segment display? It's a device used to display numbers digitally. As its name indicates, it contains 7 segments. These segments are arranged in the shape of an 8 and when activated in different combinations can represent all numbers from 0 to 9. Each segment is denoted by a letter from A to G. To display the numbers on the display, you can use a hexadecimal code which when converted to binary turns on the necessary segments of the display to show the required number. Here are the two types of displays which are the common cathode and common anode. Now I'm going to explain the code step by step. The first thing done was to configure port D as an output in MCC. We will be using the delay library to create delays later on. A defined variable was declared, which will be used as the delay value in milliseconds. Here, an unsigned variable was declared, which will be used later. This is a function. It allows us to display the hexadecimal value on the display. Inside, it has a parameter which will be used for the switch function. The switch function allows us to switch between different cases, determined by an integer where various instructions can be included. Now, the number of the parameter will be the number of the case in switch, and that case will determine what number will be displayed in the 7-segment display. For example, if here the parameter is a value of 4, then the number 4 will be shown. If it is number 0, then the number 0 will be shown. Here is the main code. It is very simple. The variable count will increase by 1. Then there is a condition. If the value of count is greater than 9, it will reset back to 0 in order to loop the counter. Here it shows that the value of port D is equal to the hexadecimal value in the function that we used. Here we see that the parameter is determined by count. And then there is the delay in which we use the defined integer. Here we have the diagram in Proteus. As you can see, we use these labels in order to connect from port D to the display without the need of excessive cables. Now we will turn it on. As you see, it counts from 1 to 9 and then it resets back to 0 and starts again. Here is the physical display. As you can see, it is connected to port D. However, we need to mind the pinout that I showed earlier in order to connect it, because it is very different from Proteus. As we can see, when it reaches 9, it resets to 0. That'll be everything for this video. Thank you for watching.